Hey guys, today we're going to be going over Leet Code question number 55, jump game. So you initially start out at the first element of an array, and you have to see if you can jump to the last element of the array. I'm going to go through why example 1 is true, and why example 2 is false. So you start out at the first index, and then you see if you can reach the last index by jumping whatever num's I would be. So on this one we can jump 2, gets us to 1. Jump 1 to the next one, 1 to 4, or how they have it right here. On step 1, you jump to 3, 3 jumps all the way to 4. And then why this one is false is because if you're right here and you jump 3, you land on 0. Right here, you jump 2, you land on 0 as well. Same with 1, so you can never reach the last index. So I'm going to solve this question using a greedy algorithm. And some key features about a greedy algorithm before I start typing it out are: a greedy algorithm makes the locally optimal choice at each step in hope to find the globally optimal choice. Greedy algorithms, they don't backtrack at all. Once a decision is made, it's final. And why the greedy algorithm is suitable for this problem is because we are trying to find the furthest possible index we can reach at each step. So I'm going to type out this problem and talk about it as I go. The solution is surprisingly simple. So we started out by just defining a simple value, and this will store our running count of what the max reach from each index is. Then just a simple for loop, and if we make it through this for loop without returning false, which we'll show in the middle of this for loop, then we return true at the end. Alright, so here's the completed solution. And what we have right here is if the index is greater than the maximum index that we can reach to, we return false, because all it takes is just 1 that we can't make it over to turn the entire problem to false. And then at the end of the for loop, we redefine max reach by taking either the pre-existing max reach from the previous iteration, or by taking the index plus num's I, because if we're on this index, we can reach the last one because we take the index plus num's I. Or if it's smaller or equal to, so if we were at this one and index plus num's I is not greater than our max reach, then we would just stick with our original max reach right here. So I'll run this, accepted, submit it, and it's accepted as well. So I will put in a couple of console logs. Alright, so I'll run this, and now you can kind of see what I'm talking about. So with the index being 0, because of right here, this is the problem that we're on, max reach turns into 3, index is 1, max reach is still 2, which these are equivalent all the way down with these ones, with 3, 2, 1, max reach and I plus num's I would all equal the same. So then once index and max reach are equal right here for the third index, so then finally the last console log is when index and max reach are equal, and what we can imagine is it goes back through again, and then I is 4, max reach is 3, so I is greater than max reach, and then it returns false for the whole thing, and as we see right there. And now we have this one to show as an example. So we have index being 0, our max reach is 2, I plus num's I, then we go to index 1, we check 3 right there, so then it turns into 4, go to the next one, index 2, the max reach isn't further, so we keep it as 4, keep it as 4, and eventually it will reach the last indice and return true from that line right there. So that is the greedy algorithm and its solution to solving Leet Code question 55, the jump game. I hope you enjoyed watching. Be sure to like and subscribe. Have a good one.